Welcome, everyone. When we talk about security in Microsoft 365, we often focus on human users. Today, we are shifting our focus to the applications and services that interact with your data. We will master app registrations and enterprise apps to ensure total security. Let's get started. Welcome, everyone. When we discuss Microsoft 365 security, we naturally focus on human identities. But in today's cloud environment, applications are accessing your data constantly. Identity extends beyond just human users to include applications and automated services. If we don't manage these application identities with the same rigor as our employees, we leave a massive backdoor open. That is why any app connecting to Microsoft 365 must be formally registered. By doing this, we maintain absolute control and visibility over what data these non-human entities can touch. We manage this entirely through Microsoft Entra ID using two specific objects, app registrations and enterprise apps. In our zero-trust architecture, applications are treated as first-class citizens. They must explicitly verify themselves, and they are granted the absolute minimum privilege needed to function. Let's look at the diagram on the screen. It illustrates how Microsoft Entra ID splits identity management into two main branches. On the left, we have the familiar human identities, your standard user accounts. But on the right, we have application identities, which are just as critical. This branch further divides into the two core objects we will master today: app registrations, which act as the global definition of the application, and enterprise applications, which act as the local instance governing permissions and access in your specific tenant. This parallel structure ensures that software is governed just like a human employee. So, what exactly is an app registration? An app registration is essentially the blueprint that defines how an application connects to Microsoft 365 and outlines exactly what that application is allowed to do. When you register an app, you are defining its core parameters. For instance, you specify what kind of users are allowed to authenticate with it. Is this an internal tool only for your organization, or is it a multi-tenant app open to anyone with a Microsoft account? Why do we require this? To ensure that only explicitly trusted applications can interact with your organization's sensitive data. Whether created manually in the Entra Admin Center or via scripting, this registration process generates a globally unique application ID. This ID acts as the definitive identifier for the software, allowing Entra ID to track every request the application makes. This flowchart shows the initial creation of an app registration. A developer or an administrator interacts with Microsoft Entra ID to register the software. Entra ID immediately does three things. It generates a unique app ID, it records the supported account types to know who can log in, and it sets redirect URIs to know exactly where to send authentication tokens securely. All of these configurations combine to form the app registration blueprint. This blueprint is the foundation of trust between the new software and your Microsoft 365 environment. Just as a user needs a password, an application needs a way to prove its identity to Microsoft 365. When an app connects, it must demonstrate that the request is genuinely coming from a trusted source. It achieves this using a digital password known as a client secret or a cryptographic key known as a certificate. You can think of these credentials like a special security badge that the app flashes to say, "I am exactly who I say I am." Why is this critical? Because if an application ID were public and lacked a secret, any attacker could spoof the app and hijack data. As administrators, you are responsible for generating these credentials, storing them securely in a vault, and changing them regularly to reduce the risk of misuse. Moving to production, always prefer certificates over secrets, as they provide a much higher level of cryptographic security and cannot be easily leaked. Let's trace the secure communication flow using this sequence diagram. First, the custom application reaches out to Microsoft Entra ID and presents its application ID alongside its client secret or certificate. Entra ID evaluates these credentials. Once validated, it issues a secure, time-bound access token back to the app. The application then presents this token to the Microsoft 365 data services, like Exchange or SharePoint. Finally, the data is returned securely. Notice that the application never accesses data directly. It must always pass the stringent authentication check at the identity provider first. After proving its identity, we must authorize the app. What is this application actually allowed to do? During registration, we define the exact information or tools it needs access to, such as reading user profiles, sending emails, or modifying calendars. Why do we do this? To ruthlessly enforce the principle of least privilege. We want to ensure that only trusted apps can interact with organizational data and that they only get the absolute minimum level of access required to function. As a deep dive, you must understand the two types of API permissions. Delegated permissions are used when a human is signed into the app, meaning the app can only act on behalf of that specific user. Application permissions, however, are used for background services or daemons running without a user. These are highly privileged because they apply tenant-wide, making strict oversight mandatory. This decision tree illustrates how we configure API permissions. When configuring access, you hit a fork in the road, the permission type. If a human user is interacting with the app, you select delegated permissions. The app acts on behalf of that user and is strictly limited to whatever data that specific user can normally access. If the app is a background service, like a nightly synchronization script, you select application permissions. Here, the app acts as its own entity. Because application permissions can potentially touch every mailbox or file in the entire tenant, they almost always require explicit, high-level administrative consent before they can operate. To fully grasp application security, you must understand the difference between an app registration and an enterprise application, also known as a service principal. If the app registration is the global blueprint of the software, the enterprise application is the local physical building constructed from that blueprint inside your specific tenant. Why do we need both? Because you need a way to govern how the app behaves locally in your organization. The enterprise application object is what you use to control who can access the app, to configure single sign-on, and to apply your conditional access policies. For example, if you want to mandate that anyone opening your HR app must pass MFA, you apply that conditional access policy to the enterprise application object. It gives IT the granular control necessary to secure applications at the local level. Here we see the relationship between these two objects. On the left, the app registration acts as the conceptual blueprint. When that app is authorized in your tenant, it instantiates the enterprise app or service principal. Look at the powerful local controls branching off the enterprise app. Local user assignment dictates exactly which employees can open it. Single sign-on configuration defines how they authenticate. And conditional access policies enforce your strict security rules. All of these funnel into complete local tenant control. You manage the code at the registration level, but you manage the security at the enterprise app level. Let's tackle a major security risk, application consent. Sometimes, third-party apps will prompt users with a screen asking for permission to access their data or perform actions on their behalf. This is a massive phishing vector. An attacker can trick a user into consenting to a malicious app that quietly steals their inbox data. To stop this, managing user consent is paramount. As an administrator, you must review these permission requests carefully and strictly limit which apps users are allowed to approve on their own. By disabling uncontrolled user consent, you prevent situations where an app gains more permissions than it really needs, massively reducing your security risks. Instead, you implement the admin consent workflow. If an employee wants to use a new tool, the request is routed to IT. You evaluate the app, ensure it follows the principle of least privilege, and then grant consent globally for the organization. This flowchart contrasts unmanaged versus managed consent. At the top, a user attempts to use a new application. If your user consent policy allows them to accept it themselves, it flows left, often resulting in a high risk of a data leak if the app is malicious. However, if consent is restricted, it flows right, triggering the admin consent workflow. The IT admin reviews the request. If the app asks for excessive permissions, it is blocked. If it is safe, the admin grants tenant-wide consent, protecting the enterprise while still enabling productivity. This is active risk management. Enterprise applications aren't just for Microsoft tools, they're how we securely integrate third-party software. Consider an HR management system that needs to let employees sign in using their existing Microsoft 365 accounts. To accomplish this, admins set up a connection called Single Sign-On, or SSO, via the Enterprise App object. This makes logging in much simpler and more secure for the end user. But the security benefits for IT are even greater. Setting this up involves configuring special identifiers, exchanging security certificates, and applying groups so only HR staff can access the tool. Furthermore, because the authentication routes through Microsoft Entra, you can require extra security steps, like an MFA prompt from their phone. Finally, centralized audit logs track exactly who signed into the external app and when, perfectly supporting your compliance efforts. This sequence shows the power of SSO. The user attempts to log into a third-party SaaS app. Instead of asking for a local password, the app redirects the user to Microsoft Enter ID. Enter ID immediately evaluates the policies attached to the Enterprise App object. It sees that MFA is required, so the user performs the MFA challenge. Once verified, Entra issues a secure SSO token back to the application, and access is granted. The third-party app never sees the user's password, and IT maintains absolute control over the login conditions. Let's tie this together with a real-world scenario. Imagine your developers build a custom Power App designed to read users' calendar information to help schedule upcoming meetings. How do we secure this? Step 1. The IT admin registers the app in Entra ID, giving the app its formal identity. Step 2. The admin sets up the API permissions, strictly limiting the app to only read calendars, and explicitly grants admin consent so the app can function smoothly. Step 3. The admin creates a special security key client secret so the app can authenticate securely. Finally, once the app goes live, the admin configures where users are sent after signing in, and uses audit logs to keep an eye on how the app is used to make sure it follows all organizational security rules. By carefully managing the app registration and its permissions, we enabled a powerful business tool without ever compromising our zero-trust architecture. Our final diagram maps out this real-world deployment. The custom Power App connects to its app registration in Enter ID. The registration is configured with a specific API permission, calendar, read, and secured with a generated client secret. Notice the IT administrator's role. They explicitly grant the admin consent for the permission, and they continuously monitor the audit logs. Because this secure foundation is laid, the custom Power App can successfully and safely request data from Microsoft 365 calendars. This represents a perfect synergy between developer innovation and rigorous IT security.
To find related ebook and other material for this training course, go to quicktechie.com. Now you will see all the video courses are available here. So let's move to the ebooks. You can go here, ebooks, all AI related ebooks like you are watching currently mythos related training. That ebook would be uploaded under this section. You can download this ebook. PDF would be available, all 300-page PDF. So you just click on the download this entire ebook. You can download from this section. So whatever training you are currently listening, corresponding ebook would be available. We have thousands of ebooks available. Now, other than that, we have on video courses which you are watching right now. This also all AI related courses are available. Similarly, for all company related trainings are available like Microsoft. You can find it here with their respective certification training modules. All exam simulators which would help you to get the certification preparation. Just refresh if you get this kind of error. Okay, so now you can see these are all certification preparation materials. Will also be click here to the NVIDIA certification preparation material. So you can see all NVIDIA certification preparation materials, and click on any of this and it would load the entire screen and you can launch the practice paper. So this is what you can see, that you can submit the answer. We have an audiobooks available. Okay, so for each section, and these are our alumni who can you can find out all alumni who are accessing our portal.